Hello, my name is Nidhi Pandey and I'm a Senior Technical Marketing Engineer with Palo Alto Networks. In this video, we will see a demo of traffic flow with Multi-VPC support in Cloud NGFW. With this feature now, we support deployment of firewall resources which can be shared with multiple VPCs. This is supported with customer managed endpoints only. And it gives you a flexibility to create a centralized security architecture where the ingress, egress, and the east-west traffic flows via the same firewall resource for security inspection. With the customer managed endpoints, while creating the endpoints, it can be mapped to the endpoint service which gets created by Cloud NGFW. If you look at the architecture here, I have 3 endpoints created in each of the 3 VPCs. I have an endpoint in the security VPC which handles the egress and the east-west traffic, and I have endpoints in each of the application VPCs to handle the inbound traffic. The route table for the egress and east-west point to the endpoint in the security VPC via the transit gateway. The internet gateway route table for load balancer points to the endpoint in the application VPC. Let's test the inbound flow now. In the inbound direction, when we try to access the load balancer, the traffic goes to the endpoint in the VPC, which then sends the traffic to the security VPC for inspection. Before hitting the application stack, we can see that we have a response from the instances in the VPC1. In my Cloud NGFW, I have an allow all rule to permit all the traffic from the firewall. If we go to the CloudWatch console, go to the log group for Cloud NGFW, and within the log stream, click on the latest log stream. This is the IP of the laptop from where I initiated the connection to the load balancer, and I have a log matching my laptop IP to the load balancer IP on the port 80, and we can see that this is a TCP connection. The destination IP is 10.1.6.59. This is the laptop IP which initiated the connection. Now let's test the outbound flow. In the outbound direction, based on the route table, any traffic towards the internet will be routed towards the security VPC for inspection. I have SSH into the instance in VPC1, and from here I'm going to send an internet traffic, and from the console we will use W3M, which is a Linux based web browser, and we'll try to access google.com, and you can see that we can access the site. We exit out, and now let's try to access the CloudWatch logs. Refresh the logs, and you can see the latest logs which has come. And if I look at the web browsing event which got generated, you can see that this is a web browsing app originated from source IP 10.1.1.1.15, which is the IP of the instance. This is the IP of the website and all the other details of the traffic which hit the firewall. Now let's go ahead and block this traffic, and let's observe that the traffic gets dropped. I'm going to just edit the same policy and change the action to deny, save the rule, and deploy the configuration. Once the configuration gets deployed successfully, let's send the traffic again from the instance. So I'm going to use the same W3M command and try to access google.com, and you can see that the connection does not go through. We will exit out and check the logs. Go to the CloudWatch console, go to the log groups, and let's check the latest log stream. And if you check the latest traffic logs, so I'm going to check against the source IP of the instance, and you can see that there is a drop action based on the rule which we had edited. And now we are going to test the east-west flow. For east-west traffic flow as well, when the traffic originates from the instances in VPC1 based on the route table, it gets forwarded to the security VPC towards the endpoint. An endpoint is going to send to the Cloud NGFW for inspection. We also have the endpoint route table which sends the traffic towards the destination after inspection via the transit gateway attachment. If If you look at the route table in the security VPC, I have a default route which points all the traffic towards the endpoint in the security VPC. At the same time, if we look at the route table of the endpoint, for the internet traffic, after the inspection, it goes to the NAT gateway, and in the east-west direction, it gets forwarded towards the transit gateway for further processing. Now, before we move ahead, I'm going to change the rule which I had set to deny to allow the traffic again, and I'm going to change the action to allow. Save the changes and deploy the configuration. Once the deployment is committed successfully, let's access the EC2 instance in VPC1 again, and we will try to send a ping packet to the instance in VPC2. So let's get the address, and the address is 10.2.167. We are going to copy this address and send a ping command to this address, and we can see that the traffic goes through successfully. Let's stop the traffic, and now we are going to change the rule in Cloud NGFW. We are going to set a match against the application for ICMP, and I'm going to search for ICMP. Once you select it, click on add to selected applications, click on add, and then I'm going to deny the ICMP packet. Click on save, deploy the configuration and commit. Once the configuration has been successfully committed, we are going to send the same ping command again from the console, and you can see that this time the packet doesn't go through. And in the log stream, you can find an entry with the source IP matching the instance IP. This is the destination IP of the instance in VPC2. It matched the application and the action is set to drop. This brings us to the end of this video. To summarize, we saw how we can share the NGFW resources across multiple VPCs and provide a centralized approach to deploying Cloud NGFW. For more details, please do visit our live community page. Thank you for watching.